Alright, we looked at the product rule for finding the derivative of the product of two functions, but how about when we're dividing one function by another? For instance, suppose we had q of x equals f of x divided by g of x. Would we just take the derivative of each one? Well, we're going to find out that it's a little more complicated than that. So let's take an example. Let's say that q of x equaled something like sine x over x squared. So we have two functions, one being divided by the other. Let's take a look at what the derivative will be. Well, we know if we look at this equation on the left that we could rearrange it so that q of x times g of x equals f of x. Now, if we wanted to differentiate both sides with respect to x, I would just take d dx of the left side and d dx of the right side. Well, we know from the product rule that would give me q prime of x times g of x plus q of x times g prime of x. And all that would equal f prime of x. But remember, we're looking for the derivative of q of x to solve for q prime of x. Okay, how are we going to do that? Well, the first step is to substitute in for q of x. If we look way back up to the beginning, we can see that q of x is just equal to f of x divided by g of x. So let's go ahead and make that substitution. Then, if we solve for q prime of x, we're going to get the f prime of x minus, well, that's this f prime of x over here, minus this entire portion of the left side. And then, of course, we have to divide by g of x. So to clean that up a bit, it's going to look like this. F prime of x times g of x minus f of x times g prime of x divided by g of x squared. So it's a little bit like, the numerator anyway, is a little bit like the product rule, except now it's subtraction. And then the quotient rule has this denominator of g of x squared. Let's take a mnemonic that I find helpful. If we have a function, q of x, and we want its derivative, here actually let's say it like this: q of x equals f of x divided by g of x. I'm going to refer to f of x as the high function because it's in the numerator, and g of x will be the low function since it's in the denominator. So q prime of x equals low d high, which means the derivative of high, minus high d low, the derivative of the denominator, all over the square of what's below. So low d high minus high d low over the square of what's below. And that's a really helpful mnemonic for seeing what the formula is, or just keeping it straight. All right, let's go back to our original example, and that was q of x equaled sine x over x squared. Well, using our new mnemonic, we'd have q prime of x equals low, which is x squared, times the derivative of the numerator, which is cosine x, minus high, which is sine x, d low, which will be 2x, all over the square of what's below, which we're going to write as x to the fourth power. Now, ugly as it is, that's the correct answer. It's sometimes nice to simplify it, so we'll get x squared cos x minus 2x sine x over x to the fourth. Now, it doesn't make it much better, but at least it's algebraically correct. Okay, let's take a look at a couple of examples, and then we'll wrap the video up. Let's take the first example of f of x equals 2x cubed over e to the x. Why don't you pause the video for a minute and try it out. See if you can figure out what the derivative of that quotient of functions is. Okay, using our mnemonic, we would say that f prime of x equals low, which is e to the x, d high, which is going to be 6x, minus high, 2x cubed, times d low, which is just going to be e to the x again. And that's all over the square of what's below, which you can write as e to the x quantity squared, or maybe better would be e to the 2x. So let's try another one. Let's say g of x equals x squared plus 3 over x. Now there's two ways to do this one. So let's look at the quotient rule first. Pause the video and see if you can do it using the quotient rule. Okay, using the quotient rule, we'll see that g prime equals low, d high, minus high, d low, and the derivative of the bottom is just 1, all over the square of what's below, so x squared. Now let's simplify that. And when we do, in the numerator we get 2x squared minus x squared minus 3 all over x squared. And you can simplify that yet again to get x squared minus 3 over x squared, which simplifies to 1 minus 3 over x squared. Alright, let's put a box around that and consider the quotient again, but this time let's simplify it first and write it as g of x equals x squared over x plus 3 over x. Now if I simplify x squared over x, that just equals x plus 3 times x to the negative 1. Now let's now instead of using the quotient formula, we have two functions being added together, so we can use the sum and difference formula. So g prime of x will just equal 1 plus 3x to the negative 2, or you could rewrite it as 1 plus, I'm sorry, that's not 1, that shouldn't be plus, that should be minus 3x squared. So you would get 1 minus 3 over x squared, which you'll notice is the same answer as you had gotten using the quotient rule. Okay, let's take a look at one more and then we'll end the video. Okay, h prime of x will equal low, d high, and since square root of t can be written as t to the 1/2, we can write that the derivative of that is 1 over 2 root t, because if you take the derivative here, you'll get 1/2 t to the negative 1/2. That's the derivative, so d dt of root t equals that, which can be rewritten as 1 over 2 t to the 1/2, or 1 over 2 root t. So low d high minus the high, d low, which is 2t, all over the square of what's below. And you can just leave it like that. You don't have to simplify it any further than that. Okay, so I hope this helps. We'll go over some of these in class tomorrow. Thanks for watching.